Welcome, everyone, to this first lecture in your engineering journey. Today we explore a fascinating question: how did engineering education begin? Where was it first formalized? And what does it mean for you, sitting in this classroom right now? We will trace the path from ancient engineering arts through the birth of formal institutions, understand the rich Indian legacy, and discover how your engineering skills can help solve the most pressing problems facing our world. This is not just history. This is the story of why you are here. Think about the pyramids of Giza. Someone had to design them, calculate the angle of the slope, organize tens of thousands of workers, and move 2.5 million stone blocks. That person was an engineer. Long before universities existed, engineering was practiced as a craft handed down through apprenticeship and guilds. The Romans gave us aqueducts that supplied water over distances of more than 80 kilometers using only gravity. Archimedes, 2,300 years ago, understood levers so well that he famously said, "Give me a place to stand and I will move the earth." But here is the key insight: all this brilliance was informal, unstructured, passed from master to apprentice. The idea of a dedicated school to teach engineering theory systematically? That is a very recent development. Now we arrive at the moment that changed engineering education forever, 1794. France was in the middle of a revolution. The country desperately needed bridges, roads, canals, and fortifications. The old guild system was gone. Who would train the engineers? The answer was the École Polytechnique in Paris, the world's first institution dedicated exclusively to engineering and science education. When Napoleon took control in 1804, he transformed it into a military engineering academy. The faculty he assembled reads like a Hall of Fame of mathematics and science. Fourier. Yes, the Fourier of Fourier series, which you will encounter in your second year of mathematics. He was a professor here. Bayet helped establish the meter as a universal unit of length. This school became the blueprint for engineering education everywhere, including, eventually, the institutions you are studying in right now. The Polytechnic model spread rapidly. Within 30 years, similar institutions appeared across Europe and America. Notice something remarkable on this timeline. By 1847, India had its own engineering college, the Thomason College of Civil Engineering in Roorkee. This was not just the first engineering college in India. At that time, it was the first engineering college in the entire continent of Asia. And 100 years later, in 1951, independent India established IIT Kharagpur, launching a chain of premier institutions that are today counted among the finest engineering schools in the world. The journey from France to Roorkee to Kharagpur to the college you are sitting in right now, that is an unbroken line of educational heritage. Let us come home now. To India. The year is 1847. The British colonial administration urgently needs to build the Ganges Canal to irrigate a drought-prone region and prevent famine. To build it, they need trained civil engineers. Their solution: establish the Thomason College of Civil Engineering in Roorkee, in what is now the state of Uttarakhand. This was not just India's first engineering college. It was the first in all of Asia. The curriculum was intensely practical: surveying, canal construction, bridge design. Theory in service of real problems. Today, that same institution stands as IIT Roorkee, one of India's premier engineering research universities. The oldest engineering college in the country, and one of the finest. India did not have just one pioneering institution. In the mid-19th century, a whole cluster of engineering colleges was established, each with its own fascinating history. In Chennai, the School of Survey was set up in 1794, even earlier than Roorkee. However, it was a survey school, not a formal engineering college in the classical sense. Today it is the College of Engineering, Guindy, under Anna University. Some historians argue it deserves the title of India's earliest technical institution. In Pune, the College of Engineering, established in 1854, is one of Asia's oldest engineering colleges, now reborn as COEP Technological University. In Shibpur, West Bengal, the Civil Engineering College of 1856 is now the Indian Institute of Engineering Science and Technology, Shibpur, an institute of national importance. Each of these institutions trained the engineers who built colonial India's roads, railways, bridges, and irrigation systems. For those of you studying in Tamil Nadu, this particular history is your own. The School of Survey, established in 1794 in Chennai, is the ancestor of the College of Engineering, Guindy, the founding institution of Anna University. Anna University today affiliates more than 600 engineering colleges across Tamil Nadu. Think about that number, 600 colleges. This is one of the densest clusters of engineering education anywhere in the world. Tamil Nadu produces over 150,000 engineering graduates every year. That is a workforce that powers not just the state but the whole nation. The decisions taken in 1794 to train surveyors for colonial administration have, through a long chain of history, led to the classroom you are sitting in today. You are part of a very long and very proud tradition. When India gained independence in 1947, the new government faced an enormous challenge: how to industrialize a nation of 300 million people, most of them in poverty, in the shortest possible time? Nehru's answer was engineering. He championed the creation of the Indian Institutes of Technology, calling them the temples of modern India. IIT Kharagpur came first in 1951, built on the grounds of a former British detention camp. That choice was symbolic. On the site of colonial oppression, India would build its future. IIT Madras, our own IIT in Tamil Nadu, was established in 1959 with collaboration from West Germany. Today there are 23 IITs across the country. Their graduates lead global technology companies, win Nobel Prizes, and hold the most influential positions in science and engineering worldwide. From survey schools in 1794 to global research universities in 2024, this is India's engineering journey. Now that we understand where engineering education came from, let us ask, what does it actually teach you? What should you leave with after 4 years? Technical knowledge is the foundation. Without it, you cannot call yourself an engineer. But the engineers who change the world combine technical skill with a broader set of capabilities. Analytical thinking, the ability to look at any problem and systematically find its solution. Communication, Fourier could not have survived at the Polytechnique if he could not explain his mathematics clearly. Neither can you. Teamwork, no significant engineering project is done alone. The person who can work effectively in a team is 10 times more valuable than the solitary genius. Lifelong learning, this is perhaps the most important of all. The programming language you learn in your first year may not exist in 20 years. The engineer who stops learning stops being relevant. And finally, ethics. Engineers have caused disasters, the Bhopal gas tragedy, the Challenger shuttle explosion, when ethical responsibility was ignored. Your degree is a license to affect human lives. Use it with care. Here is a statistic that surprises most students. Research from Carnegie Mellon University and the Harvard Business School found that approximately 85% of job success comes from well-developed soft skills, and only 15% from technical knowledge alone. This does not mean technical skills are unimportant. They are absolutely essential. But they are the price of admission, not the differentiator. Two candidates apply for the same engineering position. Both can solve the same equations. Both know the same programming languages. The one who gets hired, and more importantly, the one who gets promoted, is the one who can communicate clearly, work effectively in a team, manage their time, and think entrepreneurially. Your 4 years here should develop both columns. Do not make the mistake of focusing only on grades and ignoring the human skills that will define your career. Here is why your engineering education matters at a civilizational scale. The world faces challenges of unprecedented complexity. Climate change threatens to displace hundreds of millions of people. Water scarcity affects 2.3 billion people right now, today. 770 million human beings have no access to electricity. Over 800 million people are hungry. These are not political problems alone. They are engineering problems. Clean energy systems, water purification at scale, precision agriculture that feeds more people from less land, affordable medical devices for rural clinics, smart cities that can house billions without destroying the planet, these are problems that engineers solve. You are entering the profession at the most consequential moment in human history. The skills you develop over the next 4 years could help save lives. Now let us bring this home. To India. To the challenges that you will actually work on in your careers. Agriculture. 60% of our workforce is in farming, yet it contributes only 15% of our GDP. Precision farming, drone technology, and IoT sensors can transform yields for millions of farmers. Infrastructure. India needs 40 trillion rupees in infrastructure investment by 2040. Every bridge, every metro line, every highway, every port, they all need engineers. Water. 21 Indian cities including Chennai and Delhi are projected to exhaust their groundwater. Water engineering is a matter of survival. Renewable energy. India aims for 500 gigawatts of renewable energy by 2030. Solar, wind, and green hydrogen technologies need a massive engineering workforce. Electric vehicles. India has set a target of 30% EV penetration by 2030. Battery technology, charging infrastructure, and power electronics are key engineering domains growing at extraordinary pace. Semiconductor mission. India has committed 76,000 crore rupees to build domestic chip fabrication capability. VLSI, fab process, and embedded systems engineers are urgently needed. This is India's moonshot moment in hardware technology. Artificial intelligence, AI is transforming every sector, from agriculture to healthcare, manufacturing, and logistics. India needs engineers who can build, deploy, and govern AI systems responsibly. These are your problems to solve, not somebody else's, yours. In 2015, world leaders gathered at the United Nations and made a historic commitment. 193 countries agreed on 17 Sustainable Development Goals, a shared blueprint for humanity to achieve a better and more sustainable future by 2030. These are not aspirational platitudes. Each goal has specific, measurable targets. Each target has defined indicators to track progress. This is the world's most ambitious collaborative project. Look at these 17 goals. They range from ending poverty and hunger, to ensuring clean water and affordable clean energy, to building sustainable cities, to protecting life on land and in the oceans. Now ask yourself, how many of these can be achieved without engineering? The answer is, not a single one. Let us get specific. Here is how your branch of engineering maps directly onto the Sustainable Development Goals. Civil engineers design the water treatment plants that deliver SDG 6, clean water and sanitation. They build the resilient infrastructure of SDG 9 and the sustainable cities of SDG 11. Electrical engineers design the solar microgrids that bring power to remote villages, SDG 7, affordable and clean energy. Computer science and IT engineers build telemedicine platforms that bring doctors to villages that have no hospitals, SDG 3, good health and well-being. Chemical engineers develop water purification membranes and biodegradable alternatives to plastic, addressing SDG 6 and SDG 12. Biomedical engineers design affordable diagnostic devices that can be used in rural health clinics, addressing health inequalities under SDG 3 and 10. Whatever your branch, you have a direct line to transforming the world. India has its own SDG priorities, shaped by our specific geography, population, and development stage. SDG 2, Zero Hunger. India has 224 million undernourished people, the largest number in the world. Engineering solutions in precision agriculture, food processing, and cold chain logistics can change this. SDG 6, Clean Water. 40% of India's water bodies are critically polluted. Low-cost filtration technology and smart water distribution networks are urgently needed. SDG 7, Clean Energy. India is committed to 500 gigawatts of renewable energy by 2030. This is the largest clean energy commitment by any developing country in history. It requires hundreds of thousands of trained engineers. SDG 9, Industry and Innovation. India aspires to grow its manufacturing base significantly. Make in India, the semiconductor mission, and space technology, all depend on engineers. And SDG 13, Climate Action. India is among the nations most vulnerable to climate change. Adapting our infrastructure, agriculture, and cities to a warmer and more extreme climate is an engineering emergency. Engineering is not an abstract pursuit. It is performed by human beings who made choices to apply their skills to the world's problems. Sir M. Vishweshwaraya designed flood control gates before computers existed, using pure engineering intuition and mathematics. India celebrates Engineers' Day on his birthday, September the 15th. Dr. Kalam was an aerospace engineer at heart. He led the SLV-3 rocket program, then the Integrated Guided Missile Development Program, then became the President of India. He proved that engineering is a calling. Dr. Tessie Thomas, the missile woman of India, led the development of the Agni 4 and Agni 5 missiles, the first woman to head a missile project in India. Srida Vembu, from a small town in Tamil Nadu, built Zoho into a global software company with operations run out of rural areas, providing tech jobs to thousands who never had to leave their villages. You are the next generation. The world is waiting for what you will build. Let us put this in hard numbers. The Business and Sustainable Development Commission estimates that achieving the Sustainable Development Goals will unlock $12 trillion in market opportunities annually by 2030. This is not charity. This is the largest investment opportunity in human history. Along with this comes 380 million new jobs across sectors like renewable energy, sustainable agriculture, smart infrastructure, and healthcare technology. Think about the careers available to you. Renewable energy engineers who design solar farms that power 10 million homes, smart city systems engineers who design the mobility and waste systems of future megacities, biomedical engineers who build affordable health monitoring devices for the 2 billion people who currently lack access to basic diagnostics. The SDGs are not just a moral agenda. They are a jobs agenda and an innovation agenda. And you are being trained to participate in it. We cannot end this section without talking about the most serious aspect of your profession, responsibility. Engineers hold people's lives in their designs. The Bhopal gas tragedy of 1984 killed 15,000 people and injured 500,000. It happened because safety systems were compromised. Engineers knew. Decisions were made anyway. The Rana Plaza building collapse in Bangladesh in 2013 killed 1,134 garment workers. Structural engineers had flagged cracks in the building. Management ignored them. The building fell. These are not ancient history. They are warnings. The ethical engineer puts public safety above every other consideration, above profit, above schedule, above the pressure of management. You will face these pressures. Know now, before you face them, what your response will be. The engineering profession exists to serve humanity. Never lose sight of that. Let us bring this all together. First, engineering as a practice is as old as civilization. Engineering as a formal, institutionalized discipline is less than 230 years old. Both are part of your heritage. Second, India has one of the oldest and richest traditions of formal engineering education in the world. You stand on the shoulders of those who built canals, bridges, and dams when there were no computers, no calculators, and often no political freedom. Third, your education must develop both your technical depth and your human skills. Neither alone is sufficient. Fourth, the world's defining challenges, climate, water, energy, food, health, are engineering challenges. The 17 Sustainable Development Goals define your professional agenda for the next decade. Fifth and finally, engineering is a moral profession. The trust society places in you is immense. Honor it. And so we end where we began, with a question. You walked into this college carrying ambitions, perhaps some anxiety, and a sense of possibility. You now know that you are part of a tradition stretching back to the pharaohs, through the Polytechnique, through the canals of Roorkee, through the schools of Guindy and Pune and Shipur, through the IITs, to this moment. The world is facing its most complex set of challenges since perhaps the Second World War. Climate change, poverty, disease, inequality, these are not going away on their own. Engineers build the world as it is. Engineers will build the world as it must be. And you, sitting here today on your first day or first week of this journey, are going to be one of those engineers. Fourier, the man whose series you will curse in your second year, once sat in a lecture hall in Paris and wondered what he could contribute. He contributed one of the most powerful mathematical tools in all of science and engineering. Your contribution is waiting to be made. Thank you.